So, welcome to lecture 17 of MCS 507, a course on mathematical, statistical, and scientific software. So, the topic of today is to look at modules, packages, software licenses, and software documentation. So, these four topics kind of hang together. Um, Software licenses are very important. In my experience, I only started thinking seriously about them after I had already a substantial amount of software. I would rather encourage that you start sooner than later to think about what license you would like for your software. Um, so then there is software documentation. So the lecture will end with a tool. Now, a tool itself helps you, but it's the same as kind of typesetting. Being very proficient with LaTeX is extremely important, but that doesn't tell you how to write great papers. So, just a caution of this. Um, so, modules and packages are important to build up larger collections of softwares. So a package is essentially a collection of modules, and packaging software is extremely useful. Is actually to distribute your software. Okay. So here is a function definition. So what it actually really does doesn't really matter. It will be a function that we will export in our first package. So it's a function that takes three arguments. Now, the way it's kind of written um, is because of Pylint. So that's something that somehow escaped me. But Pylint, so that we didn't cover so far, but I should have probably mentioned this earlier. Pylint is a nice tool that kind of gives a score to your software. So in the beginning, when you first time use it, it's rather disappointing because the score is rather low. So one of the suggestions that Pylint makes is that all the arguments should be at least 3 characters long. So that's why the X arc, Y arc, Z arc. So some of the suggestions are rather a little bit artificial, but if you want to crank up your score, your Pylint score, then actually this is good to do. Um, okay, so self-contained. So every function header should be followed by a documentation string. So strongly recommended. So at the end, I will say something about documentation. Um, in the first step to write documentation, and a very excellent practice is to keep documentation as close to the source code as possible. So distributing source code without documentation is in general not really a great practice. Be kind to your future self is what I heard. So software often has a very long lifespan. So that's um, a good recommendation here. Okay, we distinguish between the function header and the function body. Often the function header and the documentation string should be sufficient to understand and to use the function reliably. It shouldn't. I know that Python is a scripting language and for rapid prototyping, but you're not necessarily writing only for Python programmers. Okay, so functions export modules. Functions are exported by modules. Modules are collections of functions, so they can be used in a first Python session just by an import. Um, okay, so this is as a module. The restriction here is that the module should be uh, accessible. So this is something that we wrote ourselves, and it is in the current directory. So this slide was made from a copy and pasting from a command line terminal session. Now, here is already a first good use of the documentation string. So now our first module exports only one function, although there's also a second function, main. So it's kind of absurd to write extensive documentation, but still, I mean, the help that comes is can be consulted online, so in an interactive session. So this description is actually what is automatically generated. So when you do help our first module, it will display under description what is in the documentation string of the module. So it's also stored in the variable doc. So this documentation string can actually also be automatically extracted very easily. So this documentation string will also show in the generated documentation. So there is the reference manual, and the reference manual is the manual that is going to be consulted by programmers. So we are still here trying to set up from the documentation from the programmer's view. Okay, so then the functions that are exported are a main function. Otherwise, this main function is also called a test function. Whenever you export a module, even if it's only intended as a collection of functions and be used as a collection of mathematical functions, then it's still very useful to somehow put some testing in there. So we talked about testing last lecture. Test early, test often. And also tests should be preferably very close to the source code. Here is the main function. So we will use the module as a collection of functions that we want to export, but also as a standalone program that can be executed at the command prompt. So here it's a very simple interactive program. It prompts for input and then it returns the output. It prints the output. So the last two lines on the module definition define essentially the action when you run our first module from the command prompt. Here we run the module as a program. If that is the case, then the main will be called. So modules still support the top-down philosophy of programming. If you import, so if you omit that next to line, so if you import this if test here in the next to last line, then it will be annoying when you import the module in a Python session. Then the main will always run, and that's most likely not the intended behavior. So this next to last line in a module, if you have a test or a main function, is rather important. Okay. I indicated that our first module was in the current folder where the Python interpreter was launched. Now, most likely this is not the case. So if you export modules, or if you download just Python code, you may want to put it in one separate folder, not in the folder where you currently work. Also, if you use the Jupyter notebook, there the distance between the execution cells with the code and where the code actually is might be quite different. So the system module exports the path, and it's just a list. And you can prepend to that list, so insert to that list the location where you want the Python interpreter to start looking. So this can sometimes have some unintended consequences. So here is kind of a trick that you want to do. If you have in your folder, in your current folder, a file math.py, and this has only these 3 lines in it, then if you import math and run the test, that will actually print the sentence that we defined in tests, so no problem here. But note that then the cosine of the math library is kind of gone. So that is something that might be kind of distressing. So the order in which the modules are consulted or loaded in the interpreter is determined by the system path. So here we got this behavior because the math.py was in the current directory, or also we have prepended the system path with a math.py that had the content of what was in this module. Okay, we can fix this. So it's the list that we actually can modify. So we can actually delete all the modules where there is the math there. So here you see how this can be done. Okay, you can do an import and you can do an unimport. That's essentially what it is. So in some sense, you could think of an application that consists of many different implementations of one function, the same function in the same module, but at different locations. At some points in the code, you import and then import a specific function for a test. So before you integrate everything, you can do some selective imports and then unimport. This could be how you test drive a patch. Okay, how do you make your own package? Not that hard, essentially. So extending Python with an extension module was kind of hard. So in a way, this lecture could have come a little bit earlier because we are still here in the pure Python world. Okay, so but it's a very flexible mechanism. So you can export Python modules. So a package is typically a selection, a list of modules, but it can also contain compiled code. So you can also distribute other files. So in that sense, your package might then be domain specific. So you could still provide a more general platform-dependent package where you load in the specific SO shared object SO on Linux, DLL on Windows, or dylib on Mac. There is a directory side packages somewhere on your installation. So most of my documentation I got from the Hitchhiker's Guide to Packaging, which is a very short but a very effective guide to making your own packages. Okay, so there is a step by step. So first of all, you have to um, be you have to have decided what is your license. So that will be next discussed. There are some files that you need to define. The most important file is the setup. So we will again use the Python setup and then make the distribution and then Python setup to do the install. So in a way, there are three steps. It's a three-step process. The last step is even optional. You could make your distribution and then make that distribution available for others to install to distribute that. So steps 2 and 3 are actually automatic. So Python setup twice. The the first step is often always the hardest. So assuming here that we have already a module of code that works and that we are happy with, so we are going to release version 0.0.1. About version numbers, um, typically one uses a three-letter version, so the last index is typically for small changes that are typically not going to be noticed that much by users. If you change the first digit, then sometimes things may break. So a first digit change is a little bit like going from Python to Python 3. Um, Okay, so how do we make our first package? So first we have our code that we put in the folder our first package. So there are folders within folders. So our first package dash 0.0.1 contains everything. So contains the setup, the readme, the license. But then there is the subfolder in there with all the code. Our first package contains the .py files, except the setup. The setup is one layer up. Okay, so in the layer up, so in the top folder, our first package dash 0.0.1, we put the license file. By default, use the GNU GPL. I will explain what are the differences. Then it put also the README file dots there. Restructured text is already quite good. So here you see restructured text. If you are familiar with LaTeX, then restructured text is actually quite simple to learn. So in complexity, restructured text is a lot easier. Okay, so we have a first README. So that README will also be generated in the documentation of the package. So if somebody does the import and then help, this is what will show up. Okay, so then there is the manifest. So we will include, so the manifest .in, so there is the manifest that is generated, and then there is the manifest.in where you include all the non-Python files. So here we will include all the text files, which are in our case the README and the license. So other files could be shared objects that you distribute in with compiled code. The version number is important. Also, one may think that we will not worry about version numbers, but again, be kind to your future selves for your users. If they are using certain versions of your software, you want to know which version was used. Okay, so then the setup. What is nice is that you can get the Python lib here. So the Python lib is somehow important to put in there. So you can also you have a short description and then also a long description. So this is the setup. Um, the get Python lib is important if you want to generate certain code. So this was for the header files. So we have only one module. So our name of the package is our first package. Um, so the folder where our code is our first module. So that is that is the module names. So we have the subfolder. So typically we could have had our first module in the same directory as our first package, but it's better to separate the code from the metadata, so to speak. Because the code for the folder also contains the init. So our first module resides at the same place as the init, which is executed when you initialize the module. Okay, so then what does Python setup.py does? Well, it creates a distribution. It creates a folder with the distribution in there. So that is everything that you are going to distribute. So this is our first package. In some sense, this is nice. Because you can still test if your distribution, if everything is in this archive is actually complete, if you did not forget anything. So you can install it if you like on some other computer and see whether everything is there before you properly then install it. Okay, so then as a super user, you can extend your Python installation with your own package. So if we import our first package, we will see the help. From our package, we can import modules. From the module, we can import the functions. Okay, so here is the help. So the help shows the documentation string, shows the version number, and also, of course, the name of the package. Having that documentation there helps you already with the bare minimum documentation that you will have to write. Okay, that was our first package. Now, what about licensing? I will mainly try to indicate what is the difference between open source software and free software and not so free software. So the history is that in the beginning, software was tied to hardware. So programmers were also users and software developers. There was actually not that much difference. Um, but the personal computing meant that users became that the users were no longer programmers, but they were also customers. So things became commercial. And the entire Unix project actually became a commercial product. In reaction to that was the not Unix, was the free software foundation, and that gave rise to the GPL licensing. So Linux is most likely the most famous GPL product. Now the open source also extends to non software. So there is the open course aware project. There are also special licensing for documentation. Perhaps I should emphasize is that as well. One can say, look, there is our software is free, but it's only free but documentation is not. So it's only free if you then buy a book, and that book is the documentation of the software, and only certain people can change it. So without free documentation, there's also no free software, and there are other requirements that need to be satisfied here. Okay, so intellectual property. So what is the purpose of a license? That's actually to make sure that the people who have the intellectual property rights, the proper authors of the software, they get to benefit from the product. So there are tools to protect intellectual property. So first of all, if you do not release the source code, then if you only give the object code, and then in the license explicitly state that the reverse engineering of the code is not possible, then well, that probably does it. So a copyright is important here. It actually gives the authors. This tells actually what you can do with the software. So you can only talk about copyright if you have the intellectual property right. So this is kind of important to begin with. You cannot license software. You cannot write a license for software where you were not the author of. So intellectual property right should actually be first and foremost. Okay. What is the two motivations? So correctness is important. So it is free as in free speech. Of course, it's also free as well. But with free speech come responsibilities as well. So the main benefit is that if you have an important software, then it typically is important that it is correct as well. So you must be open to allow for verification. So there must be the possibility to see, to verify or to falsify an outcome. The service aspect is also important here. A license itself doesn't really make a software free and open source. So there are also other issues there. I will come back to that a little bit later. Okay, so there is the copyleft, the copyright. So it's kind of a pun. But copyright tells you what you typically can't do. If you think about the GPL, the purpose of the GPL is to give the users of the software the same rights as the authors. So you give everybody all rights. So this seems to be extremely permissive. However, the license itself cannot be changed. So you have the same. So everybody who works then with the code has to accept those licenses. So there are several open source licenses. So there is the GPL license. Then there is the library license, where you are allowed to distribute modified versions only as a library. So these are more permissive licenses. There's also the practice of dual licensing, where as an author you can attach several licenses to your software. Okay, here is a flow chart. So I didn't talk much about public domain. Public domain means that there is essentially so the there is anything can so there is essentially the question for copyright no longer exists there. So this is really um, not out of the question. So open standards are often. So I mentioned here as example HTML. So that is in the public domain. Um, so the other decision is that whether you want it proprietary or not. So Windows is here listed as the proprietary example by excellence. So for open source, you have to ask your question: do you, as a user, have the same rights as the authors? Can that happen? Copyleft or not? Then the um, GPL GNU Linux falls within that. So then there are um, other open source. Um, so this is a flow chart that so there is a reference here that goes deeper into this, but this is kind of a first cut on a decision on where your software lies, but also note that it's important uh, what license is it that you rely on? So the software packages that you use for your research, in which category do they lie? So it's also important to realize that if your software, you may make it free and open source, but if it relies exclusively on proprietary software, then the notion of free and open source may actually already be compromised. Okay. Um, I will end with two reading suggestions. So this is a graduate course directed for um, researchers. So the first reference is a little bit hinting at the importance of software. So this is in the high energy physics community, where one studies where the authors study the impact of software. And the title is kind of suggestive. As a researcher, should you devote time to software or writing scientific articles? So software can have an enormously large impact. That is not often clear if you start experimenting with your software. So often it seems very ad hoc, and often it is more wrong than right. But over the long term, software might be a worthwhile investment. Funding agencies have also taken note of this. So I got to the second reference, actually through a funding um, call for proposals. The open source. So this is a very interesting paper, by the way. So it's not sufficient to declare that your software is free and open source. So it takes a community. So there is much more necessary other than having a license that supports free and open source. Um, so these are some suggestions for reading and considerations. Okay, now come the last part, another tool, and also a little bit guidance. So if you write, or if you, like in my case, you talk and you give a lecture, you should keep in mind who's your audience, who is your audience. A software guide, software means different things to different people. So the parts of a manual, so the manual is now the collection of the software documentation. It should contain four parts. First of all, there is the installation guide. How can you run it? This could be just the URL of the cloud address where your software is available. Then there is the getting started. So what is a typical use of the solver? So some manuals start with really saying the 5-minute guide. So this is also kind of the advertisement for your software. Then there is the tutorial. In the tutorial, you try to explain all the features. So think about a guided tour towards what your software has to offer. This is still directed to users. So the part one might be directed to system administrators. If you are also, yes, in the installation guide, please specify what are the dependencies, what architectures, what the requirements are. The reference manual is intended for the programmers, also your future self. And often this consists of the generated code. Sometimes, if you were not too careful about your documentation strings, the reference manual might be a very good, or in the naming of your functions, for example. So the reference manual might list, and most likely in Sphinx case, will list all the names of all the functions of all the that are exported. And so in some sense, the reference manual provides you another look as well, as a software developer. So it's important to see that all good software manuals consists of those 4 parts. Okay, so now comes Sphinx. So Sphinx is a tool. And writing excellent software documentation is also very important and is a separate job. So very similar to writing a paper. So you have the research results that you obtain, but then you have the writing of the scientific paper. So you may have great software, but if nothing is really well documented or very vague or not documented at all, your software might not be useful. Having Sphinx is important, but the Sphinx is a tool. So don't say, I know how to use Sphinx, so I have great documentation. Well, perhaps. Okay, so Sphinx is beautiful. It generates beautiful documentation. It is originally created for Python. So I think the Python project uses it as well. So it's widely adopted. It also supports other languages. So one feature that I like a lot is that you can have one source that's written in restructured text, a markup language, which you may know also from the Markdown in Jupyter cells. The same documentation you can generate LaTeX, PDF, and HTML, which is very convenient. Maintaining software documentation is a pain if it's everywhere in several formats. So you want one master document that can generate one master source that can generate several formats. So I used it actually also for lecture notes, especially since my lectures contain often a lot of documentation, a lot of source code. So it's some. So software is our first concern here, but anything that is technical, Sphinx is good for that. Okay, so there was a hitchhiker's guide to packaging. There's also a quick start, and there are only a couple of steps that you need to do. In your when you have a package, you can also release the software documentation with it. So again, this is strongly recommended. So I should have pointed this out at the packaging. So I hinted at the licensing. So if you have no free software, if your software, the sources for your documentation are hidden, then perhaps you want this because you want to have ultimate control over who releases what. But I would strongly recommend that the folder, the directory doc, is also in your package distribution. Um, so there is a quick start, and the quick start, as I remember, is interactive. There are some critical decisions, only a couple of them. It's good to separate the source from the build. The build is where the PDF files, the LaTeX code, the HTML code will get. The source is where you will put your restructured text files. Then there's a configuration where you put the path where your Python code is. So here is where it's kind of interesting. Sphinx will, in some cases, also will import some of the code. So that's another reason to put the documentation very close to the source code itself. Um, so there is the auto module. So there is the automatic generation of the modules. So all the modules that are exported in your package will automatically be have a place in the reference manual. Okay, so the documentation of Sphinx is itself great. I should just say there's not much to say here more. Um, we will have other projects. Consider writing releasing your projects. Well, it was now in the past with the Jupyter notebook, which also can document your code very well. But consider using Sphinx in your computer projects. Okay, so you can write your lecture notes like this. So the notes that you take while studying for this course, you can make your own generated notations like that. It could already be often a first draft of a paper. So with this, I will stop. I hope that these four disjoint topics, modules, packages, making your own packages, and then licensing and documentation, I hope that it was not too disjoint and that it may help you in your future software releases.